Welcome to another session of Unit 4. In this session, we are going to discuss about principle, applications and safety measures of radiotracer techniques, in particular autoradiography. As you are already aware, that there are certain elements which what we call as isotopes. They have a special property of decaying over time. Okay, so this decaying is called radioactive decay. So when they are exposed for longer time, their concentration slowly becomes half. Then after some time it reduces to its half, like this, and that means for hundreds of years it keeps on decaying, just like wood decays or flesh decays. But these things are totally different one. The decay here is because they leave or they release certain particles. Okay, so this is the basic principle that is used in a radiotracer technique. So you have certain isotopes, certain elements which over time, period of time are going to decay by emitting certain radiations. This is important because if you could detect the radiation that is emitted or the particle that is emitted, you know that these given isotopes are present in a given area. It might be a tissue or a sample. That is one thing. Next, you can distribute these radioactive isotopes in the system where you want to analyze certain things. You can identify their position. You can also quantify them in any given sample. Okay, so you are basically using the principle of radioactivity, knowing that there are certain isotopes which can decay over time by emitting the light or the particles of certain interest. It might be alpha particle or it might be beta particle. Okay, and by using certain detectors, you can actually detect the emitting beta particle or the alpha particle. And depending upon the number of radioisotopes present in a given sample, the concentration or the intensity of the particle that is emitted will vary. So if you could incorporate a radioactive element in a system of your interest, you can actually identify the position of the molecule or chemical component of your interest in a given sample. Also, you can quantify it. And this is the basic principle of radiotracer technique. So you are actually tracing the radioactive element. You are following the radioactive element. You are seeing where it goes, how long it stays, what is its concentration, because this always will be proportional to the element of your interest. Okay, so these radiotracers are used in wide range of areas, like in basic sciences, in medical sciences, as well as in industry. Radioactive isotopes usually decay, as I said, by emitting different particles. There are alpha decay, beta decay, positron decay, electron capture decay, and gamma decay. Based on the type of radioactive element you are using, your element might fall in any of these decay modes. Now, what are the different techniques that are used in these radiotracer techniques? One of them is a common radiation detectors are used. Okay, so here what we do is we add a radiotracer element. Okay, what it does, it might bind to a chemical of your interest. So you are using a radioactive element which is complementary to the chemical of your interest. So this chemical will go and bind, this radioactive element will go and bind to the chemical of your interest. That means the number of radioactive elements that are present in the given sample or a tissue or a solution will be proportional to the element, complementary element. Okay, and you remove excess of the radioactive element, excess whatever it is. So that means after this, what you are supposed to do, you try to quantify the radioactive element that is present in the sample, which is actually directly proportional to the chemical of your interest, because only the radioactive element is going to bind to the complementary element, it won't bind to anything else. So if you are using a radioactive element, it should be a complementary to the element of your interest or the chemical of your interest. So what happens here in a solution, if there is a chemical of your interest, your radioactive element will go and bind to it. So the amount of this radioactive element that is present will be proportional to the chemical of your interest. Now you try to quantify this radioactive element present in the sample that is equal to the chemical of your interest that is present in the sample. And then this can be quantified by using special detectors like gas ionization detectors and scintillation detectors. These are the common detectors that are used to detect the presence of radioactive element. This can be in any sample, especially it is used in plant tissues. So here you can actually quantify, that's very important. You are going to quantify a chemical of your interest by using a radio tracer. But you should know which radio tracer you are using, whether it is complementary to your chemical of your interest, and you should also have detection methods or detector. A suitable detector should be used. This is one way, one technique of radio tracing. The next one is imaging. Radio tracing can also be used to get an image. You want to visualize, you want to locate certain chemical of your interest in a given tissue. You want to know whether that chemical is present or not. Or then later on you can also quantify it. But first thing, you are going to locate chemical of your interest. Chemical, when I say, don't think about only the complex chemicals. I'm talking about the biological molecules here. It might be RNA or a DNA or a protein of your interest. And you all know these biomolecules are formed of basically carbon, hydrogen, oxygen, nitrogen. And there might be sulfur and phosphorus. But basically carbon, hydrogen, oxygen and nitrogen are the basic elements that are present in any biological molecule. So if you can locate particular chemical containing these nitrogen atoms or oxygen atoms, oxygen is little difficult, but nitrogen, carbon you can easily trace by using its isotope. So here you are going to use a particular specific radioactive element, try to bind it with the biomolecule of your interest, then try to get a picture image in a suitable format. That is the basic principle. And here there are actually different such techniques. One of them is autoradiography. Next one is a single photon emission computed tomography, which is also known as SPECT, and positron emission tomography. So here you might be depending on the decay techniques, alpha decay, beta decay or gamma decay or positron decay, or any even photon emission, any one of these will be used. But most commonly used technique, which you might be even learning in your next coming sessions, is a autoradiography. As the name itself says, it is autoradiography. Auto, self, graphy, a graph, a picture, and radio. So here we are using a radioactive isotope. So what happens here is that the principle of autoradiography is similar to a photographic technique, where you have a negative, then you process it and you get the actual photo. Okay, similar technique is also used here. So photons of light, they will be impinging on the photographic emulsion and they produce an image. Okay, so similarly here beta particles or sometimes even alpha particles are emitted by a decomposing radioactive element. This will be then exposed on a sheet, a particular emulsion filter, and then it might reduce certain chemicals that are pasted on a photographic film. They change their state, and which will give a latent image. Later on you can develop it. Just like a photographic negative, you are going to develop it and then you are going to analyze the image you obtained. You will be able to locate the chemical of your interest, the molecule of your interest, and later on you might also be able to quantify them. So here the emulsion, this photographic emulsion in autoradiography will contain a silver halide. Usually it is silver bromide that is embedded in a gelatin. So when these crystals of silver bromide are struck by a beta particle, see, you have a sample, a tissue which is embedded with the beta particle, the radioactive element. We already know the radioactive element decay, emitting certain particles. When these particles bombard the chemical which you have used on a photographic film, they are going to ionize the atoms. Okay, the silver atoms will be ionized and this will result in a formation of a hidden image, a image which is not visible to us but a latent image. Latent means hidden. Image is going to be formed. Later on you are going to develop it, you are going to fix it, and you are going to identify the aggregates of the reduced silver atom. Usually a reduced silver atom will be black in color. So wherever this bombardment has taken place, wherever silver halide has been reduced to silver atom, in all those areas you are going to see the black colored spots or the specks, or a particular pattern is going to be formed. And this is how you locate the chemical, the molecule of your interest. So this is the schematic diagram of the radio autograph. So here is the slide, okay, and there is a cell of your interest. Then you are actually, what you have done is that you have treated your cell with the radio labeled components, molecule. You have added a radio labeled molecule to the cell of your interest. Okay, there might be, you have used certain chemical and there is a complementary molecule in your nucleus, then this radioactive element will go and bind to the nucleus. You have used another radioactive element which has a complementary molecule in its cytoplasm, so it will go and bind to the cytoplasm. There will be binding in the cytoplasm, there will be binding in the nucleus. Or maybe there is only complementary molecule in the nucleus, but there is no more complementary molecule in the cytoplasm. In this case, radioactive element will only bind to the nucleus. There may be a third condition where there is no complementary molecule for the radioactive element at all. So then there is no binding take place. You close the sheet. Okay. What happens now when the decay is taking place? If there is a radioactive element, decay will take place. It will bombard with the silver halide and the silver halide is going to be reduced to atom. Okay. Then I said it will become black in color. If there is no radioactive element, no bombardment, no change in the colors, no silver halide is reduced to silver. So, no picture, latent picture is going to be formed. So, here you see, in this case, the cytoplasm and the nucleus are both labeled. So, this area is going to become dark. Here only nucleus is labeled, only the nuclear area is going to be dark. Here there is no labeling. There is no complementary molecule, so no labeling, no darkness. It remains same. Okay, so the picture will be somewhat like this. So this is what is actually happening. You have radioactive element, Then you are covering it with the emulsion. The decay is taking place in the next step. So wherever there is a decay, so the reduction is taking place. So then the silver atoms are going to be formed, which are going to appear black in color. When you develop it, all those areas wherever there is a element of interest are going to become black, and this intensity, the black intensity, will also vary. So if there is a high level, then dark band; if there is low, the lighter one, and sometimes it will be very, very less. So depending upon the intensities of the chemicals present, different bands are going to be formed. Okay, so this is what autoradiography is. So this application, you can localize the radioactive substance, either which is bound to the receptor or an enzyme, or it is hybridized with a nucleic acid. PET and SPECT are used for three-dimensional localization of the radiation source. Quantitative analysis of the macro autographs can be done. It is also very commonly used in analyze the length and the number of DNA. So when it comes to the DNA fingerprint techniques, we are using autoradiography. Okay. The next component of this session is identifying safety measures, because radioactive elements, we know they are, so most of them are ionizing radiations. They might cause mutations, they might make our cells cancerous. So it's always important to take safety measures. One of the basic principle is ALARA, that means A for as low as reasonably achievable. That is the principle. So you are using them because they are useful. You can detect the presence of chemicals, you can localize the molecules, you can quantify them. So the technique is useful. But at the same time, there are also side effects. That's why use it as low as reasonably achievable. If you can achieve the same result with a lower concentration, then why go for higher concentration? That is the principle of safety measures. So this is one of the best practice actually. There are three principles in this ALARA. Okay, that is time, distance, and shielding. Time, minimize the time spent near a radiation source, so that so only to, like, you need the time, you can just be there for few minutes, and after that if you can come out of it, then it is well and good. You don't have to unnecessarily stand in front of a radioactive element for a longer time. Minimum exposure, minimum time of exposure is important. Then distance, maximize the distance, minimize the time and maximize the distance. More the distance, more you are exposed to these radiations. Then shielding, shield yourself from putting something in between you and the radiation. There are shields available which you can use, so that you are not directly exposing yourself to the. Then there are certain rules for handling the radioisotopes. Always wear protective clothing, gloves, glasses. Use smallest amount that is possible. Keep materials safe and secure and well labeled, because this is important for you as well as anybody who have the chance or risk of being exposed. Monitor working area very frequently, because always check for any kind of leakages or mishandling. Avoid foods and drinks in laboratory, and wash and monitor hands after experiment. Always follow the local rules, such as for the dispensing of stock or disposal of the waste. Do not create radioactive aerosols or dust, because they are much dangerous. Maximize the distance between the source and you. Minimize the time of exposure, and maintain shielding at all time. The three principles of ALARA. So these are my references for this session. Thank you for your time.